So here we are at the Grand Avenue parking structure. This is a 4-story parking structure, and all of the traffic either has to come in here and it has to leave here. There's no other way in or out. So we thought to be able to monitor how full the parking structure is, all we would need to do is count cars at this point. Count cars going in, counting cars going out, and then you put the two together, know how many cars are parked. So what we chose was IR beam gate detectors, and they just emanate an IR beam out to a reflector that we posted on the wall and bounces it back. And so long as the sensor can always see its beam reflecting, it knows there's nothing blocking it. But as soon as I block it, it can detect that. Now, obviously I can block it, and people can block it, bicyclists can block it, so we use 2 on each side, spaced a decent distance apart, 5 or 6 feet, so that only a car-sized object can break both beams at the same time. But even breaking both beams isn't enough to actually make it count. You have to break them in the proper order, so it's directionally sensitive. So to actually increment a count, you have to break like the first beam, and then the second beam, and then the first beam would have to be unbroken, and then the second beam unbroken in that order. So all of that data from all those sensors is piped into our ARM embed board, which is programmed to send the information out over an Ethernet connection. So only when there's a change in state to save power, it's not constantly sending information, but when a sensor says, hey, I just changed my state, it'll send a message out over the Ethernet through a Wi-Fi link, and the Wi-Fi client connects to this mobile hotspot, which connects to the Verizon cellular network, and then to our servers. Our servers are running Node-RED on rack space, who knows where, it's just in the cloud. And then from that, you can download our Android app on your mobile device, and then it'll show you for this location, there's so many cars in the structure right now.
It literally count out how many spaces available?
It'll give you when we walk over, we'll show you the app and show you it in motion. You can see that it's a dial that'll show you maximum capacity of the area. And if more cars come in than the maximum capacity, people are looking for spots, it'll just show it at max. And until as many cars as went in have gone out, it won't let the count go down.
Great.
So if you want to walk over with Corrigan, he can show you the app in action.
Yeah, we need to get Wi-Fi is the only reason. And the Wi-Fi is, the farther we get from the pack, the less reliable the Wi-Fi is.
Okay.
Yeah.
Our field power solution, we didn't want to have to rely on external fixed power. So we got an 18 amp hour sealed lead acid battery, which should give us about 36 hours run time just on the battery. And we got a 20 watt solar panel to provide energy. For a full sun day, it will provide enough energy to run the system and recharge the battery equal amounts. So we calculated you'd need about 6 hours per day full equivalent sun time to keep the system running indefinitely. And that power provides power for the board, the sensors, the Wi-Fi client, and the hotspot. Ideally, we would optimize out the Wi-Fi connection and just have the GSM modem directly. So we reduce our power consumption a little bit.
Alright, so this is our mobile application. It's for Android devices. You'll see a few things. This is our current latitude and longitude. We're also using the latitude and longitude from the parking structure. So you'll see there's 3 parking structures. The closest one to us is the grand parking lot. There's also the one by the library, and then there's one that's far away. Those 2 are filled with fake data. The grand parking structure is getting real data. And so these are actually being sorted by the mod arc distance between you and the sensors. And so you can actually filter these to any known distance. So we have a filter button for 5 miles. So you'll see far away, it goes away. I think it's somewhere near Santa Barbara. So if I pick one of these, say the library, we'll get this gauge to come up. And since the library doesn't actually have anything in it, it's not going to be very interesting. So we have grand right now. So right now, from the last time we started counting, you should see it go down shortly. Unless one of them is standing in front of the sensors. And I will have to check with them. So every time a car goes in or out, the needle will update dynamically. And I can have them do it. Driver! Ah, okay. Well, he's resetting the board right now, so we should have 0 very soon. We can force an update to just kind of see what it looks like. So you'll see how the needle kind of like bounces around. And when he's done resetting, let's see. Okay. We lost power for a little bit, so our server's down right now.